So in starting with the mole, we're going to start by talking about calculating the formula, atomic, and molecular masses. We refer to these all as molar mass in our notes and when we're doing problems, but they do have different names. So as we know from Unit 2, the mass of an element on the periodic table is a weighted average of all the naturally occurring isotopes of that element. Originally, we said the mass of an element was in AMU, which stands for atomic mass unit. From now on, we're going to be using a different unit. So something to keep in mind here when we were talking about calculating the average atomic mass, one of the things the reasons why we did that was because we had so many atoms in a small sample. So we do the weighted average to give us the best possible representation. So now we're going to be using that in our mole calculations. So we're going to be using grams per mole. So grams over moles would be another way of writing it. You notice too, I abbreviated mole, M-O-L, even though technically mole is M-O-L-E. It is saving a letter, but still it's technically an abbreviation for it. We can't use the letter M because M means meters. So we have to write M-O-L for moles. So how do we go about calculating the molar mass? The first thing we're going to do is write the formula for it. So that's using information we learned from Unit 4. We're then going to calculate the mass by adding up the masses of each element in the compound. If you have more than one of an element, multiply by how many you have before you add it together, and make the unit grams per mole. So things that are very helpful in this unit, the first thing is a periodic table. Periodic table is something you definitely need. Also, we're going to be doing a lot more math, so having your calculator, bringing your calculator regularly will also be helpful to you. So thinking about the periodic table and how we go about using it, please notice a few things. I have a very blown up section here to show you. Notice on our periodic table the number of sig figs are varying a lot. So something like sulfur has 2 decimal places, while something like fluorine has 6. So sig figs is something we're going to have to keep in mind. Yes, sig figs are coming back. So when we're dealing with this unit, the thing that we have to be extra careful of is sig figs. So we're going to do something to make this a little bit easier when we're calculating the molar mass. We're always going to round to 2 decimal places before we add it together. So for example, sulfur already has 2, so we don't have to worry about it. But something like oxygen, we're going to round that to 16.00 in our calculations. It's really, really close to that right now, but if you round and then multiply, it just helps when our calculations are working out. Where this is really important is when you're doing online like vision homework, because vision is very particular. It wants a very specific answer. Also, sometimes you may notice that different periodic tables have slightly different numbers. I'm not talking, like it's going to be off by a gram, or it's going to be off maybe by a hundredth or a few hundredths, which doesn't sound like a lot, but it can make a difference on like a vision assignment. So make sure you're always using the periodic table that we provide you. So we have 3 different types of compounds. We have formula units, atoms, and molecules. Each of these represent a specific type. So generally we can call all of them particles, but specifically they stand for something else. So formula unit, that is for an ionic substance. So an example of something that's ionic would be something like NaCl. So you have, which is table salt. So it's referred to as a formula unit. I want you to be very careful when you're abbreviating formula unit. The shortest abbreviation that I'm going to accept is FM. You could do form, F-O-R-M, and then unit. That would be fine too. We just want to be careful about that one. The next one are atoms. Atoms are for elements, so these are things on the periodic table. An example of something would be boron. boron, you have atoms of boron, you have formula units of an ionic substance. And then last but not least, we have molecules. This would be for covalent substances. So water is an example of a covalent substance. It's all nonmetals. We refer to those as molecules. If you think back, these have different ways of sharing ionic and covalent the electrons. So that's why we're kind of classifying them differently. You are going to be responsible to know the difference between these terms. You can generically refer to them as particles. However, on a quiz or on a test, it's going to require these three terms. A particle is kind of like a generic term for it. So here we have 5 examples of substances. We need to go through and classify them in order to determine the type of substance that they are. And then we're going to calculate the molar mass and identify the type of particle. So K is going to be an element. I know this is an element because K is potassium. It's one thing on the periodic table. KCl is an ionic compound. I know that because K is a metal and Cl is a nonmetal. SO2, S and O are both nonmetals, making this a covalent substance. Ca3PO4, 2, is an ionic substance. Calcium is considered a metal. Phosphate is a nonmetal. And then ammonium carbonate is also an ionic substance. We have 2 ions coming together. So we're going to calculate the molar mass. So on your periodic table, I want you to find potassium, and I want you to round it to 2 decimal places. So it should be 39.10 grams per mole. You do need to keep that 0 as for our significant figures. We want to make sure we're keeping those 2 decimal places. Next up, we're going to do potassium chloride. Why don't we try the rest of them, and then we'll go through and fill them in. So for potassium chloride, you should end up with 74.55 grams per mole. For sulfur dioxide, you should have 64.06. So when you add it up, you take 1 sulfur and 2 oxygens. The next one's a little trickier because you have more things. So you would need 3 calcium, you would need 2 phosphorus, and 8 oxygens. So you can go through, get the mass of each of them and multiply them by those numbers, or however you're comfortable doing it in order to calculate the molar mass. Okay. You should end up, for this one, 310.18. If you look in your calculator, I have it here. So I have the molar mass of oxygen times 8, the molar mass of phosphorus right here times 2, and then the molar mass of calcium times 3. All added together ends up with 310.18. You would have 8 hydrogens, 2 nitrogens, 1 carbon, and 3 oxygens. So 2 nitrogens, 8 hydrogens, 1 carbon, and 3 oxygens. You should end up with 96.11 grams per mole. So the last part of this is we've just using the label to describe it. So if we had a bunch of these in a container, what would we describe them as? So for the first one, potassium, we would describe as atoms, which we abbreviate AM. The second one, we have an ionic substance, so it would be formula units, which is FM. SO2 is a covalent substance, so this is molecules, which we abbreviate MM. Another way to abbreviate molecules, this way I like the best, MLCS. You notice we can't make it MOLE because that would be mole. So MLCS is another way to abbreviate it. It's kind of like the license plate way of abbreviating molecules. And then the last two are both ionic, so they're going to be formula units as well.